So let's jump right into the crux of what chapter 2 is, and it is all about data. So the question most people are going to start off with is, what are data? So data can be numbers or record names or other labels, but you need to be careful. Not all data represented by numbers are numerical data, i.e., like if you had a number 1 to be male or a number 2 to be female, what do you look at those numbers as to categorize things? Likewise, if I just present you with a bunch of information, so 62880 or Sharia Jones or 10159, if I don't provide you any context, it's not data, it's just values. So this concept is data are not data without their context. And that's why we consistently ask you, put context to each of your descriptions. Don't just assume that we know what you're dealing with. So, howsoever, if we organize the information into a table, we can make sense of that information. If I simply say, with proper labels, we have name, hire date, a PIN number, gender, age, and salary for our employees at StatCo. This now gives context to these values that we simply have to organize into these separate columns to make this data make sense now. Now, with this organization structure, we have data that we can analyze. So on to this idea of the context and the W's. So if I ask you to give me 5, do you know what I mean? Specifically in this class, not like a high five that I'm holding up right now, but I mean the 5 W's. You might remember these from middle school, but giving the 5 W's provides context, and this context gives us information that helps us understand the data we are working with. So the context is provided by the W's, and that is who, what, and in what units, when, where, the why if possible, and how of the data. And I want you to note the answers to who and what are essential. The who and the what are the crux of the matter. But the most important question is most likely why. So if you don't know what the who and the what are, we don't know what we're doing. But why are we measuring these things is just as equally important. And sometimes that's hard with these story problems or these book problems because you're not actually creating the study. So when we do our research project second semester, you will be providing the why to your research. So let's just go over each of these W's. Let's start off with who. You'd be surprised how many people mess up with writing out what the who is. So what is the population of interest? That is what we are answering with who. From whom was the data collected? Population of interest, data collected. For example, if we're interested in tax reform, does it matter whom we ask? If we ask corporate executives, maybe plumbers, are we asking all men? Are we asking all women? Who are we asking about to understand the concept of tax reform? Likewise, if we're studying the spread of a virus, does it matter whom we study? Are we studying mountain goats, ducks, tuna, bats, snakes? This is a little timely of a reference. It does come up in the book notes, but think if you're studying the spread of a global pandemic, it matters what you are looking at. Next up, the what. What exactly are you measuring? What do you want to know? Oftentimes these will come up with the variables, the things that are changing is what the what is. So if you're looking at incidence of cancer, are you measuring the size of the tumor, the metastasis, the rate of occurrence? Suppose you want to investigate population growth of polar bears. Are you looking at the number of births or the survival rate of the cubs or the rate of occurrence? What are you measuring? When is also important, especially if we're looking at a retrospective study. When was the data collected? Do you know the month, the day, the year, the time? If we're interested in popularity of a beverage, when we ask might influence results. If I ask you what your opinions are on pumpkin spice lattes that just came out this week at the end of August, you might have a completely different opinion about pumpkin spice lattes if you haven't had them in a while. But if I'm asking you in January, February, or maybe June when it's hot outside, you might have a completely different opinion than these cold fall drinks. If the beverage is hot, is summer a good time to ask? Likewise, if you're asking about iced tea, is it a good idea to ask about iced tea when it's the middle of winter in Michigan? It's worth thinking about. If you're trying to determine the political climate of an area, let's say our school, when is the best time to ask? Is it during the presidential primary? Is it during Christmas holiday? When you ask, you're going to get different opinions. That's how public polling works and why we look at aggregates over time, because people's opinions change week to week. If we're looking at the where was the data collected? Do you know the country, the region, the state, the city? If we're looking at opinions on gun control, do you think the state that we're asking has people that have different opinions? If you're looking at Arizona, where the OK Corral was, and people carry guns on the street all the time, or are you going to a gun show? What if you're going to one of the coasts that have strict gun laws? Maybe you're going to Los Angeles or Cody, Wyoming. Maybe you go down to one of the schools in Florida that experienced one of those shootings a couple years ago that we have to deal with lockdown drills because of. Do you think you're going to get the opinions that are always the same depending on where you're asking? How about the population decline of whales? Where are we looking? Are we looking in the Pacific Ocean, the Atlantic Ocean, Japan, United States? If we're looking at Japan, are you factoring in their whaling culture versus the United States that's more likely to preserve an endangered species? You can see why the where is just as important as the when and the who. Now, if we look at how, yes, I know it starts with an H, but go along with me. How exactly was the data collected? And that does matter because it can lead to bias. So is it in person? Was it over the phone? Was it an internet poll? Was everyone able to answer? Opinions, if you ask opinions on an internet company, let's say Facebook, do you think it matters if you call someone over the phone or on the internet, or if you go to Los Angeles or Cody, Wyoming? You're going to get varying opinions based off of the access that those people have and how you ask them. So how do people get their music? Are you going to ask people at a record store? Obviously, they're going to have a biased opinion. Or if you ask an online poll and you open it to everyone, there's a difference there. Maybe if you go to Comic-Con, you're going to get different answers. And I'll bring up this online poll here because this has happened quite frequently. If you can remember a time where there was an internet poll that asked, where should Pitbull perform? You know, Mr. Worldwide. And they put this poll on the internet and it was sponsored by Walmart. And the winning location was Alaska. And this is why we don't trust any type of online polling, because people like to make bad decisions, and this is why we can't have nice things. So if you ever see any information from an online poll, I would highly suggest statistically to disregard it. Lastly, if we're looking at the W's, we look at the why. So why is the data being gathered in the first place? What question is being asked? Because that matters. If you have a why, I want to measure blank, then you're going to go formulating a hypothesis from that. So in this artificial classroom environment, you may not know why. But if you're doing your own research, why will inform the what, the when, the where, and the how that the data is collected. So let's go back to who. Let's get a little more detailed here. The who of the data tells us individual cases for which or whom we have collected data. So individuals who answer a survey are called respondents. We'll see more of that later. People who are part of an experiment are called subjects or participants. If we're looking at animals or plants or inanimate objects, we call those experimental units. We need to know the who of the data so we can understand what the data say. Now, if I ask you the simple fact, is running 100 meters in 10 seconds fast? You might think, well, yeah, I mean, most of the Olympic speedrunners run at 10 seconds or under. If you're Usain Bolt, his world record is at 9.57 seconds. That's really fast. But if I say you're looking for cheetahs who run up to 40 miles per hour, and you're looking at a 100-meter time, that might not be fast. You can see why the who is important. Okay, so I'm going to present this data table, and you're going to spend a lot of time looking at data. Often a table will be organized, oftentimes the data will be organized into a table. So this data table on the side is of subsidies, which is money, provided by New York to spur job growth, which shows the context of the data presented. The data table, if we look at this, tells us the what, which are the columns, so the company name, the grant distributed, the recapture rate, if they got the money back, and the reason for default, if they didn't pay back it, and the who. So each one of these rows, in this case, is the who. Unfortunately, there is no where, when, why, or how about this data. So if we looked just for instance to spur growth, the Regent Wall Street Hotel, they got a $100,000 grant, and they were paid back, or they paid back the state of New York, or the city, $75,000. So why did they default on their loan? They went out of business. So this gives us a little bit of context. You can see that a lot of these things, they didn't get their money back, and that's why this table is organized. But we don't actually know the context. We don't know the where, we don't know the when, the why, or the how of what this data represents. Next up, large concept here is being able to identify variables. So let's just go through this line by line. Variables are characteristics recorded about each individual. And variables are holistic. A variable will have multiple possible values. That's why we say vary. Variables have names identifying what has been measured. And so to determine appropriate variables, you think about what you want to know. Variables are the incorporation of what you want to know. Variables have values, numbers, but the values are not the variable. I'll say that again. The variables have values, but the values are not the variable. So be careful not to confuse variable names and variable values. Variables should include units defining scale and how each value has been measured. So if we're talking about distance, which is a variable, you might be measured in values of miles or kilometers or feet or centimeters, etc. You know how you measured something. We're measuring distance, and it's got a unit. If we're talking about personality, which is a variable, it might be measured in the MMPI scale, which is hypochondriosis, depression, hysteria, psychopathic deviance, social deviance, masculinity versus femininity, paranoia, psychasthenia, schizophrenia, hypomania, and social introversion. Or you could be using the Myers-Briggs measure, the extrovert, introvert, sensing, intuition, thinking, feeling, and judging, perceiving. If you know what you are, if you're an INSJ, like me, which is a pretty rare personality trait, that says something about you. That's the measurement. So to think about variable versus value, so in the previous examples, we want to be careful about confusing the variable name with the variable values. So if we're looking at distance, our variable value would be in miles. If we're looking at personality, which is the variable name, we have extrovert, introvert. If we're looking at gender, the variable values would be male or female. If we're looking at size, we'd be at small, medium, large, extra small. We can see the distinction between the what and then the how you're measuring it. So who, what, and why? The Levi Strauss Company showed a list of clothing to a sample of students and asked which clothes would be most popular. If you're thinking here what the who is, the who in this data set is not the students asked. They're providing their opinions. The who that's in this situation could be the genes, could be Levi Strauss, could be the students. If we're looking at the what, are we measuring the genes or the clothes popularity or the students? And then why are we asking this? Is this for advertising? Is this for marketing? Or is this not specified? It's worth thinking about. And that's what those homework problems that you guys have up ready for you to do at the end of the week are for. If we look at variable type, and this is how we separate the next couple chapters out in Unit 1, is categorical data versus quantitative data. So you might have heard categorical data called qualitative. I hate this word. I really do. We're going to stick with categorical data to talk about things that can fall into buckets. Qualitative is a bad way of describing things. In fact, I was at a professional development session with teachers, and we were talking about the basics of measuring data. And I heard a teacher that will remain nameless that says, "Oh, I understand the difference between quantitative data and qualitative data. Quantitative data is just about the amount of data that you collect. Qualitative data is quality data." And I just had to smack my head into my hand and bite my lip because that is in no way what I want you to think. So stick with this word, categorical. What category does it fall into? So a categorical variable has a counted value. It names categories and provides information about how cases fall into those categories. And there's different ways that we are going to picture those. So categorical examples include sex, race, ethnicity, and personality type. Quantitative variables have or is measured with units. That informs about the quantity of what is being measured. So quantitative examples are income or SAT score or weight in pounds. You notice that each one of those has units, GPA, etc. The question we ask of a variable, the y, informs how we interpret the data and how we treat the variable. And it's not always straightforward. Sometimes it is, but sometimes you guys have to make a decision. And that's the messy world that statistics live in. That's the real world. Depending on the context, sometimes it's as simple as going, okay, if I have names, hire date, PIN number, gender, age, and salary, what are the categorical variables and what are the quantitative variables? We can easily see that the quantitative variables here are salary. You could also say age, which is in years. So I'll put money, and age, which would be in years. The categorical data, the buckets that you could have, would be gender. It could be the PIN. And then there's other things. What do we do with name? Or what do we do with hire date? Date could be in terms of time. You could look at it in the year but it depends on what we are measuring and why we are including this. So sometimes this could just be a way of sorting when people came in and then other demographic information. So be careful with identifiers. Identifiers are not variables. So this idea of PIN, it could be a category. It's a number. But what does this signify, this PIN, besides the person that it's attached to? Just like your zip code, if you think about the data we collected. If you go and think zip code, that's a number, but it's not either a categorical variable or a quantitative variable. Another thing that you might be familiar with, at least in this class, because I provided you this, is a Likert scale. So, in a student evaluation of instruction at a university, one question asked students to evaluate the statement, the instructor was generally interested in teaching on the following scale. So, a 1 to 5 scale, 1 being disagree strongly, 5 being agree strongly. And if we look at this Likert scale, this measurement tool, what's the variable here? So the variable, if we read the problem, is the teacher's interest in teaching. And what are the values? 1, 2, 3, 4, 5. Or we could have disagree strongly to disagree to neutral, etc. So the question is interest in teaching categorical or quantitative? And really, that depends on how we intend to use the data, the why. So looking at this a little more closely, you know there is an order to the responses, but there are no natural units for the variable interest in teaching. It's not like money, it's not like age. So interest in teaching we would call an ordinal variable. Ordinal meaning order. With an ordinal variable, if you look at the why of the study, that will help you decide whether to treat it as a categorical or quantitative variable. So what you plan to do with the data will also determine the type. Are you going to find a mean value? Are we looking at the overall collection of students' opinions on this question? And then are we looking at the mean? Or are we simply determining a rank of interest in teaching and going from there? And this is where things get messy. This is why people don't like statistics, because it depends sometimes. And sometimes a count is just a count. When we count the cases in each category of a categorical variable, the counts are not the data or values, but something we summarize about the variable categories. So if we look at this table below, the category labels are the what. The individuals counted are the who. So the variable in this case is the degree that someone holds. The values that we're measuring is which different types of degrees people have. So high school, bachelor's, master's, law, PhD. And then we have the values here. We have the values here, the number of high school, bachelor, master's, law, and PhD degrees, and the relative frequency and percent. We'll talk about that when we get to categorical variables, but not variables here, just counts. And you can see how many we have. 2, 7 makes 9, 32, 36, 40 total people. This is where those relative frequency comes into play. 4 more slides. Sometimes a count is a variable value. Fun. When we focus on the amount of something, those counts then become values of a quantitative variable. Tracking the number of fatalities from mass shootings, which is unfortunately categorized as 4 or more killed or injured by gunfire in the US since 2000. If we look at this table here, the who is the year. The who is the year. The what is the fatalities from mass shootings. And the number of fatalities is the value of the quantitative variable number of fatalities. So in this case, the count is the value of the variable, where we see that in 2016, there were 63 mass shootings, versus when I graduated high school in 2003, there were 6. And we start seeing this creeping trend in 2016 and in 2012. Something bad happened in our country those 2 years for the number of fatalities. Last bit, identifiers. So an identifier variable are categorical variables with exactly one individual in each category. Think student ID number or phone number. Or name, social security, ISBN number for books, or UPS tracking numbers. Don't be tempted to analyze identifier variables. We want to be careful not to consider all variables with one case per category, like year, as identifier variables. And this is why the why will help you decide how to treat identifier variables. You're not just a number. You are several numbers. In this class, you are your class ID, school ID, permanent ID, and state student ID. Those are just for this class. Think about how you register for the College Board testing situation. These are how you are identified. So to wrap this up with the W's, we need the who, what, and why to analyze data. The who, what, and why. But the more we know, the more we understand, and the better we can interpret our results. The when and where give us some nice information about the context. So examples, values recorded at a large public university may mean something different than similar values recorded at a small private college. Asking about your favorite meal may return very different results at 6 a.m. versus 6 p.m. If you look at how our data collected can spell the difference between knowledge and garbage. That's a famous saying. If you just have garbage in data, you're just going to have garbage out information. So for example, results from internet surveys are nearly always garbage, garbaggio. Asking students for their GPA is garbage data. Searching school records for GPA is most assuredly knowledge, not garbage. I want you to think about a little bit why just asking someone for their GPA might not be the best way of approaching things. So before we begin to collect data and analyze data, get clear about the W's. Being certain about why, who, what, where, how, and when will help ensure your data is useful and your conclusions are valid. A few warnings for us as we venture into the night. Do not assume a variable with number values is automatically a quantitative variable. ID numbers are not variables, but identifiers. And categories can be labeled with numbers, like class 1, class 2, etc. You get the point. Now it's time to actually put this into practice. We've got our homework questions, and we've got our quiz that are up that I want you to work on for this week. I wish you guys all luck. I look forward to seeing you in class. Have a great night, Falcons.